This conference will now be
Not
recorded.
first training, that is another meeting. Yeah, hi Kavya.
All right, good morning, guys. Thank you so much for joining today's session. So my name is Dixon, and I'll be the trainer for this HL7 training. So we'll just run through quick introduction and what we are going to look at the training content, and then we'll run through introduction of yours to understand what exactly your background is, and if you have any exposure to HL7 and Mirth Connect, and also just a quick introduction of why exactly you are planning to learn HL7 and all of those aspects. So, as I said, my name is Dixon, and I have been in this healthcare industry for past 12 years, and I've worked on various types of implementations like HL7 implementations, X12 implementations, CCD implementations, FHIR implementations. So all these years I have been working on different types of implementations, designing them and also implementing them. So, and I am also working as a trainer, just because I love teaching. So, which is why I'm working as a trainer for past few years as well. So I do train online, and I have exposure to various types of interface engines like Mirth Connect, Rhapsody, Integration Buddy, Ensemble, and also Cloverleaf and other things. So these are the various types of interface engines that I work on. Connector is also one of them. And not only that, I have also worked on EHR implementations, which is to set up the applications, EHR applications, and train people on EHR as well. So that is all from my end. So as we go on, we'll get to know each other more. So I'll quickly pass on the ball to Gopal. So Gopal, you can just tell your background, what exactly you're doing right now, and also uh, if you have any exposure or experience on HL7 and what exactly you are trying to learn through this particular training.
Hi, this is Gopal. Can you guys hear me?
Yes, yes, Gopal, we can hear you. Hello.
Hi, everybody. Hi, Srinivas. Yeah, I'm working for Cognizant,
Mm-hmm.
and my experience is with healthcare payer industry. So I
Mm-hmm.
basically work with the insurance clients.
Mm-hmm.
Recently, I was asked to look at the provider space, which
Mm-hmm.
I will be interacting with the HL7, and
Mm-hmm.
also some of, I think you might be aware, CMS has come up with a new rule called interoperability, which requires FHIR standards, the API transactions between the payers and the providers, which
Mm-hmm.
is the advanced of the HL7 family. So, so I'm new to this, not new to healthcare. I've been
Mm-hmm.
working in healthcare for 13 years,
Mm-hmm.
but I'm new to the provider and clinical space, specifically on the HL7. And also, I would like to know Mirth comes with pre-built adapters for HL7 and Fire. So I thought
Mm-hmm.
like this would be, give me a better foot for the new domain that I'm entering.
Okay, that's great to hear. So, if I may ask, you said you need interoperability between providers and payers, right?
Hmm. And also
So what?
members. Yeah, the interoperability rule is primarily between the payers, members, and also peer-to-peer organization
Mm-hmm.
from hospitals and different pairs like Cigna to Blue Cross and Blue Cross to United. So it
Mm-hmm.
gives the connectivity for everybody, right? So that's the where they were using the REST APIs
Okay.
and use the HL7 Fire. I
Mm-hmm.
wanted to just get a basic understanding of, even though it's not HL7, but I just want to get myself familiarized with the HL7 and see if there is anything that you are offering on. If you remember, I asked like, is there specifically you guys are offering on Fire? So you said like we are exploring, but not right now. So I just wanted to get
Mm-hmm.
myself acclimated to the HL7.
Okay. Okay. All right. I think you spoke with Srinivas. So,
Yeah.
uh, yeah. So, all right. That's great to hear. So we'll see if this training can help you. We'll go through the content once introductions are done. So, hey Tushar, how are you?
Good morning, Dixon.
Hey,
Yeah,
good
I'm good.
morning. Great. So, Tushar, just a quick introduction about yourself. If you have any healthcare background,
Sure.
and what exactly you're expecting from this training.
Yes, Dixon. So I'm Tushar. Currently, I'm working in medical coding, and
Mm-hmm.
I have been like almost 6 to 7 years in US healthcare. So
Mm-hmm.
when I was starting my career, I was working on like EHR, EMR software
Mm-hmm.
application where I have to,
Mm-hmm.
I mean, supposed to process the medical records, but I
Mm-hmm.
don't get into a deeply in technical part. So I
Mm-hmm.
know the hospital workflow, how it plays an important role, and
Mm-hmm.
after that I moved to medical coding. Also, I'm a CPC certified, but I have like I can what I can say like craze to learn this HL7, and also I have gone through the your first or two sessions from last couple of days, and I came to know from YouTube that you are providing the online training. So I think it is good. So just uh, as you are asking about the HL7 knowledge, so I'm totally new to this field. Uh, just I have 10 or 20% idea about the how it workflows, hospital workflows, as I was working like from last 6 to 7 years in US healthcare. So in HL7, I don't have that much of knowledge, but
Mm-hmm.
after going through this training, then definitely will absorb or absorb the like most of all the chapters and all the knowledge.
Okay. All right. That's great to hear. Thank you, Tushar. All right, guys. So I'll just quickly cover on how the training is going to be. So our training is going to be in two parts. First part would be dealing with HL7, which will be for 10 to 11 sessions, where we'll be talking in detail about what is the workflow, what is HL7, how the name has come, why the name HL7 has been given, and we'll be taking a look at the structure of an HL7 message. And we'll get deeper as we proceed. We'll get deeper into what are the different message types that we want to go through, which usually covers the entire workflow of the hospital, and what are the various types of events that we'll be taking a look at. Like for example, if we talk about a demographic message, then we'll be talking about a new patient registration message and also update patient information message, and then merge message and all of these things. So in that way, we will be taking a look at all the different types of message types and event types that will which will cover the entire hospital workflow, right, starting from registration till the point where the message will go to labs and we'll get the message back from labs, and also we'll be seeing how billing information is being sent finally from EHR to PM system, till the point where the claims are generated. So when the claims are generated, that will be generated in the form of X12 messages, which is a different technology, I mean different standard altogether. But we'll not be taking a look at that one because this training is confined only for HL7. And once that is done, we'll be having a second part where we'll be going through few prerequisites which are necessary to understand the Mirth Connect interface engine. So there will be 2-3 sessions on that where we'll be covering about networking, and also where we'll be covering about JavaScript and also E4X. So these are the essential items to understand more on Mirth Connect. After that, we'll be taking a deep dive into the entire Mirth Connect application, which is an interface engine. So Mirth Connect is a famous integration engine in the industry, healthcare industry, and used by hundreds and thousands of clients today. Even they have very huge clients where the providers are more than 1,000. So we'll be going through an application tour to understand what are the various options that we have, what are the various windows that we can see through when we are creating a new interface, and also from administration perspective, how do we maintain Mirth Connect interface engine and all of these things. And we'll be taking a look at how do we implement an interface, enable interoperability between different healthcare applications, and also through the process of how do we extract data from database, how do we insert data into database, and various connectivity types, like how do we implement TCP IP type of connection, web services, and all of these things. And at the end, we'll be taking a bird's eye view, taking a look at the bird's eye view of what are the other industry standards that are being used right now, like CCD and FHIR. So CCD and FHIR will be having only 1 or 2 sessions where we'll be talking about the architecture of the message in a on a very high level overview, just to understand why they are built, and how they can be used, and where we look at standards for that. So that is what we are going to cover through the entire training. So in today's session, we'll take a leap at the introduction, and what are the various things of the hospital workflow, and what is the structure of HL7 messages. So that is all how the training is going to be. Any questions before we start?
Yeah, this is Gopal.
Yeah,
So
Gopal.
you said like you are going to talk about a brief session on fire, right? So are you
Right.
guys planning on any training on fire soon, or do you have any idea about?
Not as of now. We are planning something to be in August.
Okay,
So maybe in August we'll start a course on fire. I'm preparing some course content, so it will take some time. I just wanted to make sure that I'm covering everything on that, because I worked on few fire implementations as well.
okay,
So once the course content is ready, we will definitely launch that course.
sure. Thanks.
Yeah, you're welcome. All right, so we have one new member joining. Hey, hi Jagdish.
Hey, how
Hey, how are you?
doing good? How are you?
I'm doing good. I'm doing good. So Jagdish, we were running through introductions just to understand each other. So I have just covered what are we going to cover through this training.
Okay.
My name is Dixon, and I'll be the trainer for this training. So if you could quickly introduce yourself on what is your background, and if you have any exposure to HL7, what exactly you are expecting from this training.
I just as a BA, I'm just looking forward in getting trained with the HL7 Epic certifications.
Jagdish, your voice is muffled a lot. There is a lot of it is not clear. A lot of echo kind of thing.
Just a second.
Sure.
So I've been working as a business analyst for the healthcare industry. I'm just looking forward in getting HL7 and Epic kind of certifications down the line.
Okay. So do you have any background on HL7?
Um,
Okay. Any exposure to healthcare industry?
yes. I've been working for the healthcare industry.
Okay.
feel more clearly.
Okay, all right.
Thank you.
All right, so we'll start the session, guys. So, as I said, we'll be going through the introduction of uh, why we, so we'll be going through various aspects of hospital workflow, and we'll see why we got the name HL7, where exactly we hear this term, and all of these things. So, as you all are from healthcare background already, so I will make it little quicker to run through it. So usually I cover the HL7 basics for the reason that hospital workflow basics for the reason that whatever we are going to learn from this point regarding HL7, everything connect back to hospital workflow, which is kind of a backbone, or you can say it is a blueprint, which will be referring back to always all through the HL7 training, and also not through just HL7. We will also be referring this hospital workflow while going through Mirth Connect implementations as well. So because this is the place, hospital workflow is the place, or is the network where exactly we are going to have this HL7 being used, and also it being implemented using the Mirth Connect interface engine. So by the end of this session, we will get to know where we hear this term HL7, and where exactly it comes into a picture. And then we'll be looking at what is HL7, why the name HL7, how the name HL7 has come, and we'll also be seeing what is an interface, what is the role of HL7 in healthcare industry interfaces that we are implementing, and what is interoperability, and what is HL7 message structure. So this is going to be our session today. So before jumping into details of those things, I just wanted to cover a few basic terms which we'll be referring to all through the training. So if I'm saying CPT, we need to understand what CPT is. If I'm saying CCD, we need to understand what CCD is. So these are the general terms. PM is called as a practice management system. It is a software application used by front-end administration department or registration department, where they'll be registering patients, raising billing claims, and creating appointments, scheduling appointments, and also be managing doctor's appointment book, and all of these things. So that is a kind of a management application. As the name itself suggests, it is used to manage the practice, which is why it is called as practice management. Next one is electronic health record, which is EHR. This is this is also a software system used by doctors to store clinical data, patients related demographic data, appointments data, and also their entire clinical history. Patient's clinical history will be stored in the EHR application. So the doctors will be using it, and they will maintain entire record of each and every patient that they are visiting. Then we have HIS. HIS means hospital information system. Then we have LIS, which is lab information system. Hospital information system is nothing but PM, EHR, and in-house labs, which are all interconnected with each other, will form hospital information system, where they will be exchanging different types of different kinds of data between them, to make sure the data is transformed digitally from one place to another. And then lab information system is nothing but an interconnection between the hospital and an external lab, where they will be connecting with each other, sending out the lab orders and receiving the lab results back from the lab. So that type of system is called as lab information system. And ICD means International Classification of Diseases. So which means we'll have a, a library of codes where each and every disease has a code and a name to it. So this is an international classification of diseases book, you can say, or a library, you can say, which will be used by entire healthcare industry for settling the claims or raising claims. And so usually they recognize any disease with the help of a code from this particular library. So this is an international standard library which is used by many countries. Uh, so India is one of them who is starting to use this kind of libraries. So but it is well established in US. Every claim settlement depends on this particular ICD codes and CPT codes. So CPT is also another library where you will be mentioning current procedural terminology. Basically, what it means is once you define or once you identify one disease, doctor will be giving some medications, or he will be prescribing some treatment based on the disease identified. So the disease identified will be from the International Classification of Disease Code, and CPT is nothing but the type of the medicine or type of the procedure that has been performed, which is nothing but the treatment that has been given to the patient. So that particular treatment is also indicated with the help of a code. All of those codes are present in CPT library. Next, we have CCD. CCD is a continuity of care document. This is a document where the entire patient history is transmitted to another hospital, another HI, or in case if patient wants, they can also go ahead and take a look at the CCD or get the CCD document for their reference. Then HI is nothing but Health Information Exchange. It is a central repository formed by 10 or 15, or there is no limited number, but few different hospitals will interconnect with each other and form a central repository where they will be forming the entire uh, where they will be storing the entire data with respect to all of those hospitals who are interconnected. So we'll be taking a deeper look at HI in the last two sessions, as I said. And then IHE is integrating health enterprise. This is a standard again, like HL7, CCD, and FHIR. IHE is a standard which is used by healthcare industry for implementing CCD implementations. So we'll be talking about that as well at the end a little and see why IHE is used. So we'll jump into the hospital workflow. As I said, hospital workflow is the backbone or the blueprint that we'll be taking a look at, because this is a place where actually the requirement raised. So usually when I start learning something, I keep put up two questions: why and how. So why will let us know the requirement behind certain thing. For example, we are learning HL7 today, but we need to know why we are learning HL7. So that question will answer the requirement which was there behind that HL7 generation, HL7 creation in the healthcare industry. So the requirement is mainly because to go ahead and transmit the healthcare data which is there from one system to another system, which is why HL7 has come into play. So we'll be talking more about that in the next slide. And the question how will let us know what is the technology used behind it, how exactly it has been created, how exactly it has been implemented, and all of these things. So these are the two main questions that I usually put up, whatever new I am learning. So we'll be taking that approach today as well. So if you look at the hospital workflow, as we all are from hospital background, we know whenever a patient visits the hospital, first thing that he does is he will visit the reception desk and tell the receptionist that whether he is a new patient or whether he has been to the patient or not. And based on the patient visit, the receptionist will go ahead and create a new record or update an existing record in their PM system. So as I said, PM system is the practice management software which will be used by the front desk management. So they will go ahead and capture the patient details and register them in their registration application or PM application. So any details with respect to patient name, date of birth, gender, SSN, and insurances, guarantor information, anything which is with respect to registration are called as demographics. And then once the demographic information is captured, then they will go ahead and ask patient um, for which doctor they are trying to get an appointment for, and at what time, and all of these things, then they will schedule an appointment. Once the appointment is scheduled, the patient will visit the provider. So provider is nothing but the doctor. Usually we refer the doctors as providers. And once the patient visits the doctor, they will go ahead and doctor will try to go ahead and assess the patient to see what exactly is the problem that the patient is facing. So based on that, doctor will try to take a call just by looking at the patient, doing small observations like blood pressure or sugar or whatever it is, whatever the protocol that they have, they will follow to diagnose what kind of problem the patient is facing. If they are able to diagnose, then they will go ahead and treat the patient with the medicines or prescriptions. But in case if they don't, then they will go ahead and order certain tests which are needed for jumping onto a conclusion on what kind of problem the patient is facing. So based on that, they will take a call, they will place an order, and that order is sent to the laboratory. Once the order is sent to laboratory, lab will go ahead and perform the tests that are there. So the patient will visit the lab, they will get the test done, and the test information will be sent back to the provider. So the meeting that is going to take place between the doctor and the patient is usually referred to as an encounter. That is the term that we use in order to represent the discussion or the meeting that is going to be there between the provider and the patient. So that's always there. So in case if you hear the term encounter, it means that we are specifically talking about the encounter between the doctor and the doctor and the patient, provider and the patient. So once the result is sent back to the provider, doctor will go ahead and check what kind of problem patient has. So based on that, they will conclude on few things and they will prescribe the medicine to the patient. After that is done, they will send out the charge related information back from the provider and the lab to the receptionist, and the receptionist will go ahead and try to bill the patient. If the patient has to pay the fee directly, they will pay it there itself, or else, as we know, in US, most of the things are done through insurances. So the receptionist will go ahead and raise an insurance claim and will send out to insurance company. So there are various ways of how they go ahead and send out an insurance claim to an insurance company. It can be done either through front-end stuff, or they will have a back-end billing office where they'll be receiving the notifications in the form of HL7, and they once they receive it, they will go ahead and interpret it, and they will start updating the claims or sending the claims out from their billing system to insurance companies. And from there on, they will be using a different messaging standard, as I said, called as X12, which is specifically designed for raising claims and settling claims and all. So next we will take a look at a few workflow aspects to understand why exactly we need HL7 and where exactly we did come through this term. Before jumping into that, I would like to give you a small example so that we can understand it better. So let us say we have three different people from three different countries. Let us say we have one guy from America, one guy from India, and another from China. In case if these three people have to communicate with each other, they have to learn the language of the other person, obviously. For example, if the US guy wants to talk with Indian guy, then either the US guy has to learn Hindi or the Indian guy has to learn English. And on the other side, if you look at if the Indian guy wants to communicate with the Chinese guy, again vice versa, they have to, at least the Chinese guy have to learn Hindi or the Indian guy has to learn Chinese for the communication to be enabled. So if it is one language, they can go ahead and learn. That's not a big deal. It might take some time, but they will learn it and they will start communicating it. But what if the same guy has to communicate with 10 or 12 different people from 10 or 12 different countries? Then he has to end up in learning each and every language, and then only they'll be able to communicate with each other. So that has been a challenge. So they thought that they will come up with a common language which can be used by all the countries. So in today's world, we see that English is being used as a common language for communication. So when there is a common language, what happens is each and every person who are involved in the communication, they just have to know English, and they don't need to know what is their native language. So in our example, if you take a look at, if English is known by the Indian guy and the Chinese guy and the US guy, then all of them can communicate with each other just with one language. They don't need to learn their counterparts' native language, which is a lot of time consuming aspect when they have to interact with 10 or 12 different people from 10, 12 different countries. So at this point, they just need to know HL7, know English, and they will go ahead and communicate with each other. Similarly, in HL7 industry as well, the reason why HL7 has come into play is something the same that we have discussed in the example just now. So we'll see how. So we have a practice management system, which is a software application, as I said. Any software application will have a front end and a back end. Front end is something that you're seeing on your system. It is an app. It is the look and feel of the application. For example, if you're looking at your Gmail, you have all of your emails lined up. You have your contact list. You have your inbox, outbox, and all of these things. That is the front end. Apparently, there is back end, which is actually storing the data which is being displayed for you in the front end. So that backend is called as database. So these are the two main parts that will always be there in any kind of application you talk about. It will have a front end, which will serve the purpose of the user to see and have a user interface feel. And you will have a backend where exactly the data is being stored. So that data could be a cloud database, or that could be a local database. So there are many different technologies that we use to store the data where exactly we want to store the data. So in our example, we are going to look at a standalone application, which is practice management system, which is storing the database in its database, which is storing the data in its database. In the same way, we have an EHR application. Again, that's a different software, so it will have its own database. Different softwares will have their own databases, so those databases cannot be clubbed with each other. So in our example, whenever the patient gets registered, the patient data will be stored in the database of that PM software application. And we have electronic health record. Whatever the operations or whatever the actions that are being performed on a patient will be stored in electronic health record. But the point here is, whenever the patient information is getting registered in the PM system, that has to flow over to EHR, because doctor has to know what is the patient name, what are the details, and doctor also has to know what are the appointments that he has. So after pulling out that record, doctor will go ahead and enter the clinical history of that particular patient. So when this has to happen, there has to be certain type of bridge which is going to connect between PM and EHR system. So what they used to do earlier, when HL7 was not in play, they used to have an engineer who can go ahead and write a program which will extract the data from the PM database and will insert the data into the HR database whenever there is any event. So when patient gets registered, the patient registration information will be extracted from the PM system and will be sent to the or inserted into the HR database. But the caveat here is, patient will go ahead and pull out, engineer will go ahead and design the data extraction model from the PM system based on the architecture of the database of the PM system. Similarly, on the other side, he will design the data insertion model based on the database architecture of electronic health record. That says that the engineer who is going to deal with this interface should have a thorough idea on the architecture of the PM database as well as EHR database. So if it is just one database, then that's fine. They can go ahead and research, learn it, and then do it, which will take time ultimately. But what if we have a scenario where we have to connect more than one application? When there is a need for connecting more than one application, it is obviously very, very difficult for them to learn. First thing. Second thing, learning will take a lot of time. And once once it is learned, then building the interface will take again a lot of time to go ahead and build it and then insert the data into the destination database. So that was a big challenge. Okay, so which is why they have come up with an idea of having a common language. So when I refer to language, it means the standard that I am referring to. So they have come up with a common language called HL7. So they said that PM will generate the data in the form of HL7 and will send it to whoever needs them. And the receiving party will have to understand HL7. That's it. They don't need to go out and have an in-depth knowledge on what is the architecture of the database on the other side. So when PM is extracting the data from PM database, it will extract it and it will generate an HL7 message, which is the common medium of standard or common language to understand, and send out that HL7 message. Now EHR will receive that HL7 message and it will interpret that HL7 message because it also understands HL7, and it will interpret that HL7 message, pick the data elements from HL7 and write them to the database. So that is what an HL7 that is how HL7 has started as common medium of communication, common standard of communication between different healthcare applications. And it was really a boom to the entire healthcare industry for the reason that before that communication was a big key, but however they haven't had a proper solution. But after HL7, it really boosted up the uh, way applications are being interconnected. Advantages are like now the engineer doesn't need to know the architecture of other databases. Second thing is it is faster in implementing. Uh, Other thing is the other parties, whoever is involved in this in an implementation or planning to connect to the PM system or EHR system or lab system, all that they have to know is HL7. They don't need to bother about how exactly the other party is going to interpret it, because they also know HL7 and they will be interpreting the HL7 based on their knowledge on HL7. So we'll see what is an interface. An interface is nothing but, as I said, now in our previous slide, we saw that we have to transfer the data from PM system to EHR system, right? Because it doesn't make sense for the doctor to go ahead and enter the patient details again once it is captured at the PM system. So that captured demographic information will have to flow over to EHR so that doctor can have all that basic information beforehand, when the patient is arriving. For that to happen, there has to be an interface between PM system and EHR system. So it is nothing but a bridge, you can say, which will connect from one end to another end and carry some data elements from one end to the other end. In our case, we are going to transmit an HL7 message from PM system to the EHR system to send out the patient demographic information or appointment information or so on. So anything which is connecting two different applications and transferring the data or transmitting the data, that is called as an interface. It is just nothing but a tunnel, you can say, or a bridge, you can say, which is connecting two different applications. Now, when we talk specifically about HL7, another advantage is if we are using HL7, we don't need to worry about the database, the native database architectures. For example, in the example that we are seeing here, the PM system is built on SQL database and electronic health record is built on flat file database, which are two different database models altogether. However, if we have HL7, the engineer on the PM side has to just go ahead and extract the data, send out an HL7, and at the same time, the EHR engineer has to grab that HL7 and then understand it, and then write the queries to insert the data into their EHR. Both of them don't need to interchange or don't need to understand what is the architecture of the opposite database. So what is HL7? As I said, it is a international standard which is designed to go ahead and exchange the data between different healthcare applications. It will enable exchange of data, integration, sharing of data, and it will support the clinical practice in a very large way by minimizing many things like time consumed to go ahead and generate a claim, settle a claim, and also many other healthcare related services. And this is mainly used in US and Australia and UK, and it is being used in other countries as well, as we are growing in as well, proceeding into the future. There are implementations in Dubai, Abu Dhabi, and few East Indian countries, and there are implementations in India as well. So where we are implementing HL7 related implementations. So we need to know how the name HL7 has come into play. So it is based on the concept of OSI model. So we'll be taking a look at OSI model in the next slide. Very quick view on that to see how exactly the name has come up. But that is the way how the name has been designed. It is designed on OSI layers. So more than 28 countries are using HL7 today. So there are the countries like Argentina, Australia, Brazil, Canada, and all the countries that are mentioned on the screen, all of them are using HL7 as of today. So we'll see why the name HL7 has come up. Before that, we need to understand what is OSI model. OSI is nothing but operating system interconnect, which means this is the architecture of the data, architecture of the OSI model on how exactly the data is being transmitted from one system to another system. Now let me give you an example. You are seeing what I am seeing on my screen. I am sharing it and you are seeing it, right? But how is that possible? How exactly that is being carried out, or how is that executed? Now, whatever you are seeing on the screen is the actual software layer that you are seeing. It is a presentation information or application information that you're seeing on your screen. But just imagine that behind it, there are another 7 layers to it. Okay, just imagine those as films, which are there, which are arranged in uh, serial format, one by one, one behind the other, one behind the other. So we have 7 layers even before you see what you're seeing on the screen. So what happens is, when I am presenting this, there are 7 more layers behind, and the last layer is the actual physical layer, or the port layer that is connected to my laptop, the network cable which is connected to my laptop. During these 7 layers, the data will be converted into packets, and those packets will travel through the cable that is connected to my laptop, and through the physical layer, which is the final layer which is connected to my cable. Through this cable, the packets will travel all through the network, through the internet, and is reaching your system. And when it is reaching your system, even your system has the port, which is the physical connection that you have to your system, desktop or laptop. That physical port will receive the packets and it will go in the reverse direction. So if you see here, from my end, what's happening is it is starting from here. It is going to start from here. Slowly it will change the data. It will convert the entire data into physical layer packets, and it will finally send that through network. And once you receive at your end, the data here will travel through, will be received at the physical layer in your system. It will slowly convert the data and will finally present it to you in the application layer. That is how we are exactly seeing the data from one place to another. This is the basic concept of how networking works, uh, and how data is being exchanged between different systems. This principle applies to everything. Even when you open Google, even when you open YouTube, whatever it is, the data is always traveling in the form of packets. And that mechanism of transmitting data from what you're seeing on the front end, which cannot be touched, which cannot be felt, but that will be converted into packets, and that will travel through a physical wire, the Ethernet cable and the fibers that are interconnected with each other, and will reach the other end, whoever wants to communicate with. Whoever, or if you're looking at Gmail, the Gmail server is the endpoint where Gmail server will receive the packets and it will interpret those packets. How that is done, that is a big concept, that is a huge concept of how packets are being transmitted, how they are serialized. So there are many other things that happen in the network layer, data link layer, and all of these things. Uh, so the reason why we need to understand this is the HL7 message generation always happens in the application layer. It is always and always is happening in the application layer. So HL7 is operated in the application layer, which is the 7th layer of this OSI model, which is why the name HL7 has given. HL7, as the name itself suggests, it is health level 7. So as the level 7 application layer is being used, the name has been given behind that. So that is the reason why we see the name as HL7. Next, we will take a look at an overview of HL7. Like any other HL language, we have HL7 with its own grammar and syntaxes, which we'll be taking a look at the end of the session. And we have many different chapters. The most famous one and the most longest one which is used in the history is 2.3 version, which has 12 chapters and 5 appendices. And then we have more than 50 data types and more than 80 message types. And we have more than 86 event types. We'll quickly take a look at the history of HL7. So as I said, 2.3 is the one which is used for the long time. So many implementations that are there in the industry has used 2.3, 2.3.1 versions. But later as we proceeded, we got new versions like 2.4, 2.5, 2.8, and 3. So 2.4 is released in 2000, 2.5 is released in 2003, 8 is released in 2004, and 3 is released in 2015. You'll be seeing 90% of the interface implementations will be as part of 2.3.x, sorry, 2.2.x, 2.x, which is 2.358 or something. But with respect to 3, you will be seeing very, very few implementations. Only a handful of implementations will be there on version 3. And the reason behind that is version 3 is kind of, we can say it is kind of flop. For the reason that version 3 has changed the entire structure of HL7 message. Personally, I feel that it has been changed completely. So a move or a shift from the existing 2 version to 3 version by the industry was not very much welcome, for the reason that the entire structure, look, feel, everything has been changed from what was there in 2, which is why not many people went for implementing HL7 version 3 implementations, and they did stick to HL7 2.x itself. So which is why you won't be seeing much of healthcare implementations which are involving version 3. Still, as on today, if there has to be a new implementation, they will prefer going with HL7 version 2, because their other interfaces might be on version 2, or even if it is a new implementation, they prefer to be on 2, because 3 is not, as I said, not widely accepted and not widely implemented, and the resources, learning resources and also understanding resources on 3 are very less, very, very less in the internet. Then we have FHIR. FHIR is Fast Health Interoperability Resource. This is the latest standard of HL7 organization. But that being said, it is not an HL7, not similar like HL7 messaging standard. HL7 messaging standard is based on a different concept. FHIR is based on a different concept. Now, many will ask, many people usually ask me whether FHIR is going to replace HL7. So there are a couple of questions to it. Whether or not HL7 can be replaced by FHIR, yes, there are ways how FHIR can replace HL7, but that is not the main purpose of HL7. Even FHIR can be replaced by HL7 if required from technical perspective. If you talk specifically from technical perspective, you can do it if you want to, but there are ways of doing it, but that's not the right way of doing it, which is why HL7 has its own purpose in the industry. FHR has its own purpose in the industry. FHR is not built to replace HL7, but HL7 FHR is built for some of the things that HL7 cannot do in the industry. So for example, HL7 is completely an event-driven messaging methodology, which we'll be seeing in a few minutes, how it is an event-driven messaging methodology. But HL7 is an event-driven methodology, whereas FHIR is resource-based implementation methodology. In FHIR, we will see that we are connecting different third-party applications with the actual source system, whereas in FHIR, we are transmitting the real-time data from one system to another system. Okay, so that is how both are different from each other. So as we are in today's world, we talk more about mobile apps, third-party apps, wearable integrations, and all of these things, which is why FHIR has become so famous, because that uses a model which can integrate all of these things with the EHR application or the PM applications, which is why we are hearing the term FHIR a lot. But HL7 will still be in place. Replacing HL7 is a very big deal, because the entire backend architecture or the structure is already built by all the hospitals, by all the clinics in the USA. Now, people won't prefer moving to FHIR because that is not designed for it. As I said, HL7 has its own advantages. Next, one more important thing, when we saw at the beginning of the session, we spoke about PM and EHR as two different applications. So it depends on the software that we are purchasing. PM can be a different software, EHR can be a different software, but you'll also be seeing few softwares which are kind of combined console and have different modules. And like if you talk about Epic or Cerner, they will have one single application, and everything is within that one single application, which means the PM database and EHR database are not different. Everything is stored in one database and everything is present in one application. However, they have modules present within those applications, where each of these modules, for example, registration module will be different and can be accessed only by the front end desk. The nurses and doctors will not have access to registration module. So in that way, there are few applications which are kind of a combined console. So it depends on the workflow or the application acquired by the hospital in order to go ahead and use them. So everything is dependent on that. So what are the advantages of HL7 Message? So it will help, it will provide the ability to share medical data, demographic data, billing data with any HL7 enabled applications, and where data transfer is happening in the form of messages like HL7 messages, and there are no special tool requires for creating the message except for interface engine. And then the code that you're seeing, or the HL7 message that you see, is in ASCII format, which is nothing but the regular normal keyboard used words or symbols or whatever are there. So if you understand HL7, you can interpret what the message is saying, and it can work on any OS. This is the beauty of HL7. HL7 can work on any OS for the reason that it is operating at the application layer, if you remember. So as it is operating at the application layer, it is independent of the OS which is being used, whether it is Linux, Mac, or Windows. All of these use the same principle of those 7 application layers that we spoke to transmit the data from one system to another. So all of these have application layers, and as all of these have application layers, it is independent of the OS system that is being used. It doesn't matter. And it can connect from any system to any system, because all that it needs to do is to generate an HL7 and send out, and the other system which is receiving it has to understand HL7. And it will assist in access to the overseas market, as we know. So it will give a greater flexibility to interconnect from one system to another, one state to another, which is a very, very big thing. Connecting from one hospital to another itself used to be a challenge, but today we see that in United States especially, the central government is getting the entire data from all the different United States they have. So why do we need standards? So standards are always required so that we can share the medical data, and this will help in quicker insurance claim payments, and it will enable interoperability, which is nothing but one app talking to another app. So in our case, PM talking to EHR, EHR talking to lab, and all of these things are enabled with the help of interoperability itself. So this interoperability has been enabled, was possible because of HL7. And we obviously will have a greater safety for patient records, patients and all. And then above all, we'll have very good quality of data transaction that is going to happen. Now let us see how HL7 messaging works. So we'll loop back to the same concept of hospital workflow. So when we talk about hospital workflow, what is the first thing that happens? Patient is coming to the registration desk and patient is getting himself registered. So when the patient is getting himself registered, that is called as an event. He is registering himself, and receptionist is going to capture the data. They will capture the demographic information. They will save that in their system. When they click on save, that is saved to the database. This particular aspect, right, starting from the patient arriving at the front desk, receptionist capturing the data, and then saving that in their system, is called as one event. And then patient is scheduled, getting an appointment scheduled, and sending out that appointment information to the doctor's desk, patient visiting the doctor, and then scheduling a lab for himself, for the patient. So these all things, the entire workflow is broken down into events so that we can deal with each and every individual event. So patient registration is one event, patient appointment scheduling is one event, doctor placing an order is another event, doctor receiving result is another event. So in this way, there are events that are happening in the entire hospital workflow. So this event is generating the necessity for the data flow from one system to another. For example, the registration event that happened just now, once the registration is concluded or saved, or once the patient record is saved, this patient data has to travel from PM system to EHR system, right? That is a necessity that we have. So this data is being transmitted from PM system to EHR system based on an event. So that event which is generating the necessity for the data to flow from PM to EHR is called as a trigger event. This is the standard HL7 definition, you can say. The real world event is called as trigger event. So the entire HL7 is written from an assumption that events in the real-time world are generating the necessity for data to flow from one system to another system. Okay, so all the HL7 events are based on this principle. All the HL7 messages are based on this principle, that there are events happening in the workflow of the hospital. Each and every event is going to generate the necessity for patient data to flow, appointment data to flow, billing data to flow, and all of these things. So we have examples here on the screen, an observation, which is nothing but an order placed by a doctor, and patient demographic information when the patient is getting admitted or getting registered. So that has to flow from PM to HR. So these are the different kinds of events. So we'll broadly categorize them, and then we'll take a deeper look in what are different events in the future sessions. But if you broadly categorize them, we have 5 different types of events in the hospital workflow that we have seen. One is registration. So registration deals with registering the patient or updating patient details, or updating their existing details or adding some additional information, and all of these things. Second is appointments, which is nothing but scheduling appointments with doctors and different departments for the patients who are arriving. And then once the patient is at the doctor's desk, they might place an order for lab and then receive the results from the labs. And after that, finally, they will send out the charge related information back from labs or EHR back to the PM system. Once that is done, based on the billing information received, the PM system or billing system might generate a claim and send it over to the insurance company. So now we'll take a look at anatomy of an HL7 message. So to understand that better, we'll quickly take a look at an example. Let us say we have a rack. Okay, there are 3 shelves on the rack. Each shelf is is dedicated or representing some kind of material. First shelf has clothes, second shelf has books, third shelf also has books. Okay, let us say that. Now in the first shelf has the name. It has the name of clothes. Second shelf has the name of books. Third shelf has the name of books as well. Let us say there are 2 people in the house who has this rack, and one of the guy is leaving the house for that day, and he went out. After going out, he understood that he has to go ahead and he has to get a t-shirt. Now the first guy who is outside the house calls the second guy who is at home and says that I need can you get me this t-shirt. The guy at the home immediately will go ahead and reach out to the rack. He will pick the t-shirt from the first compartment and he will give it to that guy who is outside. Now if you observe, there was no communication between the first guy and second guy about the location of the t-shirt where it is stored, because everyone in the house knows what is the design of that rack. They know that first shelf will have clothes and first compartment will have t-shirts. So there are more compartments to it. Second compartment has trousers, third compartment has shirts. Similarly, another example is whenever there is a power outage at your house, what is the first thing that you do? In today's world, we are just searching for our mobiles to turn on the flashlight, right? But in olden days, we see that either mom or dad or any one of them from the house, any elderly person will immediately go out to a location. Let us say mostly it is kitchen, where they will grab the candle and lit the candle up. Even if it is dark, even if they cannot see anything, they will navigate to that place. They will take that candle and they will lit it up. In the same way, if I ask you where you keep your keys, there is a dedicated placeholder for keys as well at your home, where you'll be even if it is dark, you will be able to point to that and you will be able to reach to it and you can take it up. All of these things are possible because there are dedicated placeholders or dedicated locations for these materials that we are talking about, which everyone knows. HL7 also work on the similar principle. So in our case, what are the data components or what are the materials? Now, candle is a material, keys is a material, which we are now, t-shirt is a material. In terms of HL7, these materials are nothing but the data elements that we are capturing at the front end. For example, when we talk specifically about a registration message, we are going to grab patient name, patient first name, last name, his date of birth, his SSN, Gmail address, email address or physical address, and all of these things. These are different data elements that we are going to deal with. And in HL7 terms, these data elements will have dedicated placeholders as per this example. So to see what are the dedicated placeholders, first we need to understand the architecture of the HL7 message. Same like this rack. If the architecture of this rack is understood, whoever is going to trying to access the rack, they will understand where we have what. In the same way, if we understand the architecture of the HL7, we will understand where we have what. So let us quickly take a look at the architecture of the HL7 message, and we'll conclude after looking at the architecture for today. I know it's extended for 10 minutes. We'll be completing that in another 5 minutes or so. So any HL7 message that you take, it will have segments. So you can compare or visualize this back to the rack as a shelf. One rack can have multiple shelves. In the same way, one message can have multiple segments. And one segment is again divided into compartments. So each shelf can have different compartments, and that is called as a field. A compartment is called as a field. These fields can be further divided into components. Components can be divided into subcomponents. So for now, we need to understand till components, so that once you understand better on HL7 structure, later you don't need explanation to understand what a subcomponent is. So we'll quickly take the look at the architecture. As I said, so we have a message. Each message will have segment. So each of these block that you're seeing here is representing each of these segment that you're seeing here. This one, this one, this one, this one. Each of those are segments. And each segment is again divided into fields. Okay, we have fields that are present within each segment, and each field is again divided into components. So there will be components present within the field. So this is like a tree kind of structure. You will have a segment, segments will have fields, fields will have components, components will have subcomponents. So like any other language, HL7 has its own grammar. So this is the basic architecture of HL7 message. We'll be taking a look at real-time HL7 message to understand it better. So this is the architecture of any HL7 message. Okay, now we'll take a look at the grammar. Like any other language, HL7 has its own grammar. For example, in English, when you're writing in English language, you see that we have spaces between two words, and you have comma to say to halt the sentence for a second, or pause the sentence, I can say. And we have full stop to terminate a sentence, and then we have exclamation marks, we have colons, semicolons, and various things to express various kinds of things in grammar from a grammatical perspective. In the same way, for HL7 as well, we have little grammar that we need to know, so that we can understand how the message design, how the message is working. So we have a segment terminator. You can compare this to a full stop. It represents end of a segment. So we'll have carriage return. It is called as a carriage return. CR is the symbol that is used. Usually this represents that the segment has been terminated, which means that is the end of the segment. Next, we have field separator. Field separator is nothing but it is going to separate the compartments. As I said in the example before, we have fields within segments, and each of these fields has to be separated with something. For example, in a sentence, if you have to separate two words, you have a space. In the same way, if you have to separate two fields, we have to have a dividing factor. That dividing factor is nothing but pipe. This is called as pipe that you're seeing here, the one that you're seeing here. This one, this is called as pipe. This symbol is present on your keyboard just above the enter key. So that is called as a pipe, and this is a field separator in our HL7 message. Then you have carrot. This is not the vegetable carrot, it is called CART carrot. This is used for separating two components within a field. Okay, and then we have subcomponent which are separated with the help of ampersand. And then we'll talk about field separator, repetition separator, and escape character later with the help of examples. That is when we'll understand better. But for now, these three things are very important to understand. Okay, especially even if this is not understood for now, that's okay. But field separator and component separator is very important. Based on that, we can understand the HL7 message. So we'll quickly take a look at sample message to understand how the architecture is. So we'll see an HL7 message. So this is how an HL7 message looks like. So each line is going to represent one segment, and I have divided them. Basically, they will be all together, but I have divided them so that we can have a very clear view of what HL7 message is. So as you can see, we have these symbols called as these symbols, which we have seen in the previous slide. We have these symbols called pipes. So we have these symbols called as pipes. Here we are seeing here, we are seeing here, and all of this. Wherever you see it, you have all the places with these symbols. So what are these symbols representing? Let me paste this on a notepad, then we will quickly see through the structure of the message. All right. So if you look at an HL7 message, as I said, I separated this, so you are seeing an additional CR. But this is one segment, this is another segment, this is another segment. Let me remove them for now. So these are 5 different segments that we are seeing. As I said, HL7 will have segments, and each segment is again divided into fields. So each segment that you are seeing here has a CR at the end, which is nothing but a carriage return. So having this will represent the end of any HL7 message segment. So which means that this is one segment, this is one segment, this is another. At the end, you will definitely have this CR, and this is one, this is one. So we have 5 different segments. Each segment is having an acronym at the beginning, which means that each segment has a name. So the first 3 letters of any HL7 segment will represent the name of that segment. This is MSH, which means message segment header. This is EVN event. This is PID, which is nothing but patient identification, and so on. So we'll be taking a look of these things, these segments in the future anyway. But for our understanding about HL7 message structure for today, we'll take a look at PID segment. So if you look at PID segment, we are seeing these pipes, right? So from here on, the data begins. And in case if you want to write, for example, we have what are the data components that we capture at the front end. We'll have patient ID, and then we will have patient first name, and then we'll have patient last name, and then we'll have patient gender, and patient date of birth, and so on. There will be many other data elements that will or data components that will be capturing at the front end. So as you can see, all of these data concepts, patient ID 0078, and then we have patient name, first name, test, last name, last test. I'm just giving a sample test name. And then we have gender as male, and then we have some kind of date of birth. Okay, so these are the data components that we have. In this case, we have represented this with a space so that each of these data components are being, or data elements can be separated from each other, and we can have a clear view. In terms of HL7, these spaces are nothing but pipes. We have seen it, right? These are pipes. This is how we represent in terms of HL7. This is patient ID, this is patient last name, first name, gender, and date of birth. That is what we are seeing here in the PID segment now. So I gave this as an example so that you can understand it. Now we'll take a look at the actual PID segment. So if you look at PID segment, we have something here which is called as set ID, which we'll be talking about in the future sessions. And this is the patient ID. So the entire patient ID is present here. This is also the patient ID, and here you can see the name, here you can see the date of birth, here you can see the gender, and so on. This is the patient address, and so on. So we have dedicated placeholders for each and every data component that is being there at the that is being talked about at the front end. Patient ID, this is patient name, and so on, as I said, and we will navigate through it with the help of numbers. This is called PID1. This is field number 2. This is field number 3. This is field number 4. This is field number 5. So whenever someone wants to represent a name of a patient in an HL7 message, they will store it in PID5. PID segment, field number 5. This is where they are going to store the patient name always. The entire patient name is present in PID5. That is how we usually navigate through the HL7 message. Can we have a patient name in PID4? No, that is not possible, because if you remember the example that I have said, we have clearly defined that first compartment should have t-shirts, second compartment should have trousers. Now we cannot go ahead and pick up t-shirts and put it in the second compartment where it is dedicated for trousers. In the same way, in HL7, each and every data component that we are going to deal with has a dedicated placeholder, has a dedicated field number, and data should be present there only. You cannot go ahead and use it wherever you like it. Okay, so PID 3 and 4 are for holding patient ID, PID 5 is for holding patient name, and PID 7 is for patient date of birth, 8 is for patient gender, and so on. If you don't have data there, for example, patient is not ready to give his date of birth information, for example, that particular field will be left over blank because that data element is not present. If it is not present, it doesn't mean that we bring the next data element little forward. Okay, so we have dedicated placeholders for each and every field, and this is how the HL7 message is designed. We will talk little more deeper of how to interpret an HL7 message in the tomorrow's session with the help of special tools that we want to use. Okay, so any questions, guys? Any questions from today's session?
So you analyze it to your database is connected with HL7, right? What is the backend language for this thing?
Is that Jagadish speaking?
Yes, yes.
Jagadish, can you type it in the chat? Your voice is really muffled. I cannot understand clearly.
Hey Dixon, this is Gopal.
Yeah, Gopal, tell me.
Yeah, first of all, thanks for the overview.
You're
It's very helpful
welcome.
because I have exposure to EDI X12, what you mentioned, right? So we have a similar kind of loops and structures. So I'm able to easily follow the HL7. So do we have any for X12? We have like implementation guides, right?
Right.
Where there is a 837 transaction. Likewise, for these clinical, do we have implementation guides?
Yes, we will. I mean, yeah, we will have implementation guides. You can find them on Google or HL7 website, wherever it is needed. You just need to type the message type like you're doing. For example, if I want to get 837 implementation guide, I just type that in Google and I'll get it. In the same way, you can type ATA04 implementation guide or and so on, and you can get that on Google. No problem.
Sure, thanks. I will do that. And the other question is like the like Srinivas shared me a recording of previous classes, but do we have anything material or something shared from this class, or I need to use the one that is shared by him?
So for every session, I have materials. So I'll be sharing that. Usually what we do is we have a Google Drive, which will be shared with
Okay,
all the participants. And on a daily basis, I'll be posting those PDFs to the Google Drive, and you can pick
oh,
it from there, the material that we are going to go through.
sure, thanks. And the last question.
Sure, no
So
problem.
every day we'll be meeting the same time, right?
Yes, yes, 7 a.m. Right.
Okay.
But session will be for 50 minutes. 10 minutes will be given for questions. Today being the demo, the content is a little heavy. So the first day session will always be for 1 hour, 15 minutes or so.
Okay. Yeah.
But daily session would end in 1 hour, within 1 hour.
Sure.
Yep. So Jagdish's question is, what is the backend language used in between the DBs? I'm thinking that this is about what language we use to generate HL7 messages and interpret them. Is that what you're? Yeah. So that's the question. So we are going to use JavaScripting with the help of a tool called as Mirth Connect Interface Engine. So Jagdish, before you joined, we spoke little about Mirth Connect. So Mirth Connect Interface Engine is a tool, is an application which is used to develop interfaces between two different applications. So using that, we'll be connecting to the databases of each on either sides, and we'll be pulling out the data with the help of JavaScript. And I mean, I wouldn't say explicitly JavaScript, but we have the tool is designed in such a way that we can extract the data, we can write the queries within the tool, and we can extract some data, construct an HL7 message with the help of JavaScripting. And then finally, after generating HL7 using JavaScript, we'll be sending it over to the destination. And if we are on the destination side, we'll be receiving HL7 message onto the Mirth Connect application, and we will be interpreting that with the help of JavaScript again. And then finally, we'll writing it back to the database using SQL queries. So if it is database to database connection, that is how we usually work through. But the essential middleware is the interface engine application. In our case, it is Mirth Connect. There are many interface engine applications in the market, like Rhapsody, Cloverleaf, Connector, and there are many other things. But Mirth Connect is one of the famous one which we are going to train on. Any other questions?
Diction, when we receive today's recording.
Mm-hmm. So it will take an hour to process. So once that is done, as soon as that is done, Srinivas will go ahead and upload it.
Sure. Thanks,
Yeah.
Dixon.
Yep. All right, guys. Any other questions you have? Okay, great. So I'm not hearing anything. So we'll catch up tomorrow morning. So as we have seen today, what is the hospital workflow? What is the message structure? Tomorrow we'll start our session with the message structure. How do we navigate through it? What are the different tools that we have in the industry to better read the HL7 message? And then we'll be taking a deeper look at what are the various events, what are the various message types that we usually come across, and then we'll start taking a deeper look at each and every segment and field. Thank you so much for joining for today. We'll catch up tomorrow morning. Thank you, everyone.
Thank you.
You all have a
Thank
good
you.
day. Thank you.